care of the safety of others, Harry. You don't seem to be doing such a great job when it comes to yourself. I'll have to keep a closer eye on you. What are you doing here anyway? I didn't know you went in for old junk.
Old junk? Listen, everything you see on this table represents an accident. What's more, it's all 600-volt equipment, the kind used in commercial and industrial buildings.
Well, I couldn't have picked a better time then. Harry, do you remember when you first joined our staff?
Do I? I really let myself in for something that big.
All right, Harry. Nothing's going to hurt you. Not anymore. We've got an important job for you, if you're interested.
I thought my working days were over.
Not yet. We need a troubleshooter. Someone who can guard people who become involved with electricity. We think you're the man for the job. Safety is a never-ending task, Harry. And we really need someone with your experience and qualifications.
Need me? That's a laugh. I could have used them. You got yourself a man.
You can start right away. You've done such a great job, we thought we'd expand your activities to take care of the people who work around higher voltages. Well, take these accidents. I'll bet that in most of them there wasn't anything basically wrong with the equipment. After all, it's designed to be safe, or it wouldn't have the CSA seal of approval.
But equipment, like this switch box, it can become defective, and it's mechanical as well as electrical. If it's poorly maintained, it becomes worn and dangerous just that much faster. Under adverse conditions, 600 volts will arc and burn, just as this one shows. Misuse, sheer misuse. Looks like it was hit with an arc welder, nearly new, too. Do you know what ionization is?
Ionization? Oh, dear. And we covered it in training school, too.
Well, normally air is a pretty good insulator, but when a high voltage arc occurs, air ionizes. It changes its composition so that it actually conducts current. When that happens, the arc continues to burn and grow until...
There's an explosion or a fire.
Right. At least temperatures get so high that components will melt and run all over the place to cause further arcing. Or it sprays out like the blast from a shotgun.
I thought it would knock a person flying.
No, not necessarily. That's why it's got to be treated with respect.
Harry, you're really a professional. That's why you were picked for the job.
Say, do you know what a delta circuit is?
Uh-uh.
It's a three-phase circuit. And if you remember, many flashes and fires are caused by a ground fault in a three-phase circuit.
The current for an ungrounded delta or three-phase circuit is supplied from a three-phase transformer. A voltmeter connected between any phase and ground will read about 347 volts if the circuit is functioning normally. In a circuit that is functioning normally, the voltage phase to phase, in this case, is 600 volts. But the voltage from phase to ground, due to the capacitive effect of the conductor, is about 347 volts. Should a ground fault develop in any phase, the voltage to ground on that phase will drop to 0. And the voltage on the other two phases will rise to 600 volts. Delta or three-wire 600-volt systems are usually used to operate motors and have different characteristics from star or four-wire systems used for 600-volt lighting, where a grounded neutral is necessary. Often, several installations, even in separate buildings, are fed from a single three-phase transformer over the same delta circuit. This can sometimes present a problem should a ground fault develop in one building. As illustrated in the previous diagram, the building where the fault occurs has a voltage drop to 0 on the faulty phase, while the remaining buildings experience a rise to 600 volts to ground on the phases not affected by the fault in Building D. A similar situation can develop in a single building where the service from a three-phase transformer is used to supply a number of different departments. A ground fault in one piece of equipment will again produce zero potential to ground in the affected phase and cause a rise to 600 volts on the other two phases throughout the entire building. The resulting strain imposed upon insulation and other equipment might, under certain conditions, lead to failure and create a second ground fault. This now means that we have a short circuit through the ground, which would undoubtedly cause a shutdown of the plant. High amperage in the system could now cause extensive damage to equipment and possible injury to operators.
Well, that's the story of 600 volts.
There's your call to action. And don't worry, Harry. You'll do all right.
Hey, wait a minute. And just what do you think you're doing with that pigtail?
My job. Any objections?
I've got plenty of objections if that's any indication of the way you do your job. Boy, you sure are asking for it. That's a 600-volt three-phase circuit, man. You stick this 110-volt thing in there and that bulb will explode faster than you can blink. Use a voltmeter or a ground fault detector for checking the circuit. They just for decoration, or were you actually going to wear them? Ah, see you don't break all the rules. Good. Rated for 750 volts and tested in a lab last month. Now get yourself a proper voltmeter and we'll check the circuit.
Well, looks like it's nothing worse than a blown fuse. We'll take care of that in a jiffy. One of these days, maybe they'll put in circuit breakers. And I'll be able to tell right away if the circuit's open.
Now what do you think you're doing? Where's your fuse pullers?
In the box.
Well, that's a right handy place for them. You sure do ask for it. From the look of these battle scars, I'd say you've been living on borrowed time for quite a while. Say, how about slipping on those safety glasses? Now you look like you're in pretty good shape. Say, don't forget.
Stand aside and turn your face away when you throw the switch on, just in case there's a flash when the circuit picks up the motor's starting mode.
Haven't you forgotten something? I said, haven't you forgotten something?
No?
Aren't you supposed to check for ground faults before you go ahead with the job?
Oh, yeah. Yeah, I guess I forgot. Well, everything looks pretty normal.
Yeah, without testing. I'll show you something else that isn't normal right off the bat. This blanket looks like it was left out in the sun, folded up, instead of rolled in a protective container. Ozone has caused it to deteriorate.
Oh, come on. Those little cracks shouldn't make all that much difference.
You're darn right they make all that much difference. High voltage electricity can penetrate even a pinhole, so every crack in this blanket means that much less protection. Get yourself another blanket, one that's in good shape and been tested recently, and a voltmeter.
Well, I guess I'm ready to make my tests.
Hey, wait a minute. What the heck is it now? Let me see that voltmeter. Yeah, that's okay. You'd be surprised how many people take chances by using the wrong tools and equipment. What about your eye protection? That's the one.
Switch is around the corner.
Which one?
Circuit 21.
Right. Hold it. Hold it there.
What's the matter?
That switch you opened back there is for a 600-volt lighting circuit.
600? I thought everything in here was 110.
Now, that's the kind of thinking that can get you into trouble. You should always take the right precautions. Make sure you know the voltage as well as the circuit. See? 600 volts. That's not the kind of system to second guess.
Yeah, you're right. I should have checked it myself.
Someone thought enough of you to identify and label all the circuits.
The company's only been here a few months. I really don't even know my way around yet.
Man, it only takes a fraction of a second for someone to get hurt. Now, all the boxes are clearly marked, and it only takes a second to check. Hey, look at this.
Never mind about that. Get me some rubber gloves.
I'll never get used to traveling this way.
Welcome back, Harry. You've had a busy day.
You look like you've had the day off.
Not at all. I had to keep an eye on you.
Oh, how'd I do?
Pretty good, Harry. You know, this equipment was all designed to be safe as long as it was treated in the correct manner.
Right, if it's CSA approved, it's safe, when you follow the correct procedures.
Well, 600-volt circuits aren't to be fooled with. Check thoroughly whenever a piece of electrical equipment fails to function before you attempt any repairs.
That's right, now you're learning. If it's a ground fault and you can't locate the fault in your own building, ask the power utility to check other buildings on the same circuit. Come over here. Follow a preventive maintenance schedule to ensure that your personal equipment is always in top-notch condition.
And regular testing should be done by a qualified laboratory.
Always air check your gloves every time you use them.
And always use the personal safety equipment designed for 600-volt work.
Use the right tool for the job. Makeshift and shortcuts are a good way to...
Join our little group, Harry.
And don't be in a hurry. We won't have a vacancy for a long, long time.
And don't forget.
Tell the people you work with not to fool around with 600-volt equipment. Let the professionals who know how to handle it take care of the problems.
Well, Harry, you've done such a good job, I'm going to let you buy me a heavenly cup of coffee.